Hello everyone. We're going to look at the atomic charge and earthing today. These are the learning objectives. The first learning objective is for you to be able to state that there are positive and negative charges and the charge is measured in coulombs. The second learning objectives is you need to be able to discuss the differences between electrical conductors and insulators and state examples of each of these objects. And then the third learning objective is you need to be able to state what is meant by earthing a charged object. So let's start. We'll first talk about the electric charge and where it comes from. Charges come from the atom. We have a symbol for the electric charge, which is capital Q. And as you know, an atom comprises of negatively charged electrons, positively charged protons, and neutrons, which do not have any charges at all. The unit for electric charge is coulomb and it has the symbol of capital C. So do not confuse that with charge. The symbol for charge is Q. The symbol for the unit for charge, which is coulomb, is C. These particles, the proton and the electron, have the same charge, which is 1.6 10 to the power of minus 19 coulombs. So the proton is positive, that charge, and the electron is negative that value. So negative 1.6 times 10 to the power of minus 19 coulomb. We can measure charges using a device called a coulometer. Now let's move on and talk about insulators and conductors, what they are. I'm pretty sure you know about them already. Insulators are materials that do not allow electric charges to pass through. This is because in insulators, the electrons, these are the negative charges, cannot move about freely within the insulator. They are stuck inside their own atom. So they cannot move about and go to another atom and so on. So electric insulators do not conduct electricity at all and are charged by friction. So you can only charge insulators by rubbing two insulators together. And this is something that we looked at in the first lesson for this topic. Conductors, on the other hand, is just the opposite of an insulator. So they allow electric charges to pass through. Some examples of conductors are copper, gold, and silver. Usually they are metals. The main reason why metals are good conductors of electricity is due to the fact that they have free electrons. These electrons can move anyway, and so because of that, they can go around easily and can flow within the object, and therefore electricity can flow quite easily within a conductor. Other electrical conductors include graphite and liquid solutions that have electrical charges that are free to move. So liquid solutions must contain ions if they are to become conductors. If they have no ions, there are no conduction. An example where a liquid that doesn't have any ions at all is distilled water, or otherwise known as pure water. Will not conduct electricity as it does not have readily available ions or there are no dissolved ions within it. So if you add salt into pure water, into distilled water, what you are doing, you are adding ions into the solution, and therefore this salt water will conduct electricity. Now let's talk about discharging. So discharging is just the opposite of charging. Charging is when you give more charges to an object. So an object can become positively charged and negatively charged. You can charge an insulator by rubbing them together, rubbing an insulator with another object. So this is something that we looked at in the first video lesson. You can also charge conductors. We haven't talked about this yet, and this is something we'll look at in the next video lesson or in 2 weeks from now. So don't worry about it. So once you have a charged object and you want to revert them back into normal or revert them back into neutral status, meaning they have no charges at all, what are some of the things that you can do? So if you have an insulator, one of the best ways to discharge an insulator is to heat it up. And that's basically it. For a conductor, on the other hand, this is much more an involved process. So a charged conductor can be neutralized. So that's just another word where we remove the excess charges so that everything is neutral, everything balances out by a method called earthing. to Earth is to provide a path for excess electrons to flow away from the conductor to the Earth or from the Earth to the conductor. So we'll do an example and I'll show you what this means. Okay, let's say you have a conductor, a metal sphere. It's isolated. That means let's say it's made from an insulator. So the metal sphere is not touching anything. So the charges inside cannot go anywhere. So it's isolated. And let's say this metal sphere is charged and it's negatively charged. That means there are a lot more electrons inside. So how do you discharge this sphere and make it neutral? What you do is you earth it. When you are earthing, you connect the object to the earth. So like that. Okay, basically you take a piece of wire or whatever conducting material you have and you just connect it to the earth. Okay? The symbol for earthing is this symbol here, as you can see. So what happens when you earth a conductor? So inside the earth, there's actually a lot of charges. So you can see the earth acts as a reservoir for these charges. You have a lot of electrons inside the earth, you have a lot of protons inside the earth, and generally the earth is neutral. So when you connect a conductor to the earth, especially a charged conductor to the earth, what's going to happen is that the electrons will then move from the conductor and down to the earth. So it will begin this earthing process, and then at the end, you'll have a neutrally charged metal conductor. So now let's say you have a positively charged metal sphere, a positively charged conductor. So we can earth this and we can make it neutral by earthing, connect it to the earth wire. So what's going to happen now? You might think that, oh, okay, so what's going to happen is that the protons will then move to the earth. No, that's wrong. Like I said in the first lesson, protons do not move because they are heavy. So how does it get neutralized? So what's going to happen? Protons do not move. The electrons are the ones that will move. So the electrons from the Earth will then move up and go to each of the protons to neutralize them. So this one will go here, and they will pair up basically in order to neutralize the conductor. So they will go like that. And at the end, you will get something like this, and everything is neutralized. All the positive charges and negative charges are equal and they cancel out each other. You can also just remove them because you know that that means they're just neutralized now and you get a neutral object. All right, so to summarize, there are positive and negative charges. The positive charges are protons, the negative charges are electrons. And the unit for charge is coulombs. Don't forget about that. And you need to know what's the difference between a conductor and an insulator. So the difference is insulators, they do not allow charges to flow through. For conductors, they do. And you need to be able to state examples of each of these materials or each of these objects. So for conductors, these are typically metals like gold, silver, copper, iron. And for insulators, these are usually non-metals like plastic, rubber, paper, and so on. And also we looked at earthing. So when it comes to your exam, you need to be able to explain how earthing happens. If you have excess negative charges inside the conductor, the negative charges will flow to the earth. But if you have excess positive charges in the conductor, then the negative charges from the earth move to the conductor in order to neutralize the conductor. Okay, so next lesson, which is part 3, we're going to look at charging methods for conductors, especially this method called separating of charges by induction. Until then, stay safe.